September30. Today we will learn about electronic configuration. Electronic configuration is actually the arrangement of electrons around the nucleus. Electronic configuration gives a specific location of electrons in the atom at ground state and in the not really excited state, only at the ground state. So I will explain what the ground state actually means. This electronic configuration has been explained with the contribution of many different scientists. But as you know, that Bohr was the first scientist who ever talked about the arrangement of electrons around the nucleus. We call it a planetary model. He said that the electrons travel in a specific path around the nucleus. Just like when you are stepping up the ladder, you can either stand here or here or here. You cannot stand in the middle of the two steps. Same thing, electrons cannot be found anywhere in the middle. They are either in the first energy level, second, or third. So he really explained this whole system of arrangement of electrons in terms of 4 quantum numbers. Okay, we will learn how to do the electronic configuration, how to do the orbital diagram, and all that. So first of all, the first terminology we need to learn is the ground state. Ground state means lowest energy state. So if there are multiple energy levels, the energy for the very first level, the one that is closest to the nucleus, is the lowest energy. As we go further away from the nucleus, it gets higher in energy. This is why we call them energy levels, because they have different energies. And as I said, the one that is close to the nucleus has lowest energy. And this is the only one that is called ground state. Anything above this is the excited state. So when I write the electronic configuration, you will see it written out like this. But let me explain first of all how things work. So here is the nucleus. Bohr said that the electrons travel in specific path around the nucleus, and this path is called orbit. And the orbit that is close to the nucleus has less energy, and the orbit that is away from the nucleus has more energy. So this is the lowest energy level, and in this situation this is the highest energy level. Okay, how many energy levels any element will have, it depends which period it's in. Okay, so this element that I just draw right now, that means it is in the period 5 of the periodic table. So everybody who is in period 5 have 5 energy levels around it. Anyone who is in period 1 has only 1 energy level around it. Anyone who is in period 2 has 2 energy levels around it. So this is how the energy levels work. As I said, this is the ground state, the lowest energy state, and this is the highest energy state. There was a scientist, his name was Aufbau. Okay, so according to Aufbau, the electrons always fill in the lowest energy level before they jump up to a higher energy level. So let's say if I have 30 electrons that I have to fill in, I will always start from the lowest energy level. I have to complete this, then jump up. I have to complete this and then jump up. Now, how do I know that how many electrons go to each energy level? Bohr explained this by the quantum number called principal quantum number. Okay, principal quantum number, and we represent it by n. Okay, principal quantum number is represented by n, and so this is n equals 1, this is n equals 2, this is n equals 3, this is n4 and n5. So Bohr gave us the formula of 2n squared to calculate the maximum number of electrons in any given energy level. Maximum number of electrons in any given energy level. So for example, if I want to find out how many electrons can go to the first energy level, that means n equals 1. So I plug the numbers in, 2 times 1 square, so it will be 2 times 1, which will be equal to 2. So that means the maximum electron that I can place in the first energy level will be 2. So if I plug the number in for the second energy level, like n equals 2, so if n equals 2 and I plug that number in, 2 square, so it will be 2 times 4 equals 8. So maximum electrons that I can put in the second energy level is 8. So based on the 2n square, it goes 2, 8, 18, 32, and same thing you can do the math. So again, Bohr explained this maximum number of electrons by the principal quantum number, and each energy level is represented by n. and this gives us the size of the atom. So if the element maximum energy levels is 3 versus an element maximum energy level 1, it tells me that this one is going to be larger in size because it has 3 energy levels around it, compared to this one, which will be smaller in size because it has only 1 energy level around it. Anyway, after principal quantum number, we move on and we go to the next quantum number, that is called azimuthal quantum number. Okay, that gives us the sub-levels, the how many sub-levels each energy level has. So according to Pauli, there are different sub-levels. So the number of sub-levels is equal to the number of energy level you're talking about. Okay, when I say sub-levels, there are 4 sub-levels. So first of all, there are energy levels, and those energy levels are further divided into sub-levels. Okay, energy levels can range from 1 through 7, and the sub-levels will range from 1 through 4. So there are 4 sub-levels: S, P, D, and F. Their names, the letters S, P, D, F come from their shapes. Sphere shape, peripheral, dumbbell. This is where the S, P, and D is coming from. And if this is the sub-level, then we need to know how many electrons each sub-level can take. S can hold 2 electrons maximum. This P can hold 6, D can hold 10, and F can hold 14 electrons. This is the maximum number of electrons that can be placed in the sub-level. I can put less than that, but no more than that. So what I'm trying to explain here is that these are the energy levels, and these energy levels are further divided into sub-levels. Now, how many sub-level each energy level has, it depends on the energy level. So if it is energy level 1, it has only 1 sub-level, S. If it is energy level 2, it has 2 sub-levels, S and P. Energy level 3 has S, P, and D. Energy level 4 has S, P, D, and F, all 4. And then it repeats because maximum is 4. So what I'm saying is that the energy level 1 has only 1 sub-level. Energy level 2 has 2 sub-levels. 3 has 3 sub-levels. 4 has all 4 sub-levels. And then 5 also have 4 sub-levels because 4 is the maximum number you can have. Now, I already told you how many electrons they can maximum take. I told you that S can take 2 electrons. Okay, S can take 2 electrons, P can take 6 electrons, D can take 10 electrons, and F can take 14 electrons. And this is pretty much it. That's all pretty much you need to know to do this math. So let's say you have 7 electrons in your hand, and you need to distribute them. So according to the Aufbau principle, you will start from the lowest energy level. So lowest energy level is 1, and in that energy level 1, you see the sub-level S. So S can hold 2 electrons. So I'm going to put 2 electrons in S. And I cannot put any more than 2 because according to 2n square, maximum electrons I can put in here is 2. And those 2 electrons are sitting in the sub-level S. So I have 7, so I jump up. And again I see S and P. So S is the lower energy level. So I put 2 again in S. So it's already 4. I have 3 more to go. So I put 3 in the P. Okay. Although P can take 6. Okay. But I have total of 7. So when I went to first energy level and I saw sub-level S, and I gave it 2 electrons because S could take 2. Then I jumped up to the second ring, which is the second energy level, and second energy level has 2 sub-levels, 2S and 2P. I put 2 in S and I put 3 in P, so because the total was going to be 7. 2 plus 2, 4, plus 3, 7. Why did I go to 2s before I go to 2p? Because according to Aufbau, electrons always go to the lowest energy level. S has the least amount of energy, then P, then D, and then F. So you need to understand the sub-levels. There are 4 sub-levels, okay? And among the 4 sub-levels, S has the least energy, then P, then D, and then F. Okay, this is how the energy goes. So whenever I have to fill the electrons in, they will always go to S first, and then they will go to P and D and F. So I'm going to draw this the circle that I had drawn before, so to make it a little bit clear. So these are the energy levels. So let's only do 3, or maybe maximum do 4. And then we said that this is 1, 2, 3, and 4, and this is N. So N1, N2, N3, and N4. So then they are divided into sub-levels. So 1 has only one sub-level, 2 has 2 sub-levels, 3 has 3 sub-levels, 4 has all 4 sub-levels. S can maximum take 2, P can take 6, D can take 10, and F can take 14. So let's say I have 13 electrons in my hand. So how do I go? I start from the, according to Aufbau principle, I start from the lowest energy level, the ground, the lowest energy state. So I put two electrons in here because S can maximum take 2. So I put 2 in there. Then I jump up and I put 2 here because S can take 2. P can take 6, so I put 6 in there. So this is complete. Because remember, with 2 and square, I had the number 2, 8, 18, 32. So the 2 here are in the S, the 8 is 6 and 2. So let's see how many electrons I'm done with so far. 6 plus 2 is 8, plus 2 is 10. I have 3 more to go. So again go to S and I put 1 here. So let's write down what did I do so far. I went to energy level 1 and I saw sub-level S and I put 2 electrons in there. Then I jumped up to energy level 2, which is right here. Okay, the 2 has 2 sub-levels. So I put 2 here and 6 here. Then I went to energy level 3 and I put 3S2 and 3P1. So if you do the math now, 2 plus 2, 4, 10, 12, and 13. So you have 13 electrons. Now in this 1 and 2 and 3, these are the main energy levels, quantum numbers, the principal quantum numbers. Like 1 represents this first energy level, the 2 represents the second ring, and the 3 represents the third. So if I draw this one, this particular element, it has first energy level that has 2 electrons, it has second energy level that has 6 plus 2, 8 electrons, and it has third energy level that has 3 electrons. So the outermost shell is 3. Okay, this is called valence shell, and the number of electrons in there are called valence electrons. All right, and whoever this element is, I don't know who this element is, but this element must be sitting in the third period of the periodic table because it has 3 energy levels around it. So this is how the electronic configuration works. So let's see what the notes tell us to do. So it is telling you that the 1 gives you the energy level. Okay, the letters gives you the sub level, and the exponents gives you the number of electrons. So the energy level, how many energy level you have, it depends on the period number. Okay, so everybody in period 3 has 3 energy levels. The sub levels are divided, you have 4 sub levels. The exponents represent the number of electrons in the sub levels, and adding the exponents should be equal to the total number of electrons, which is actually your atomic number. Your periodic table is actually divided into the sub levels. So when you look at your periodic table, the first 2 groups, group 1 and group 2, are called S block elements. We call them S block elements. These are called D block elements. Okay, and these are called P block elements, and these are called F block elements, because this particular sublevel is partially filled for these elements, and this particular sublevel is partially filled for these elements. Okay, what it means is that everybody in this group, it has P1, this is P2, P3, P4, P5, and P6. P can hold maximum up to 6. So that means P is being filled in this area, and it goes from D1 to D10. So D is being filled in this region, and this is S1 and S2. So S is being filled right here, and F1, F14. I will go over it in the class as well. Maybe it will be easier if we do it together in the class. But I just want you to know that your periodic table is divided by the sublevels. And from there on, we will work together in the class. So you have to do the electronic configuration. So let's see, who is this electronic configuration for? 1s2, 2s2, 2p5. So how many electrons are there? It's 9 electrons. So you need to see that which element has 9 electrons. So fluorine has 9 electrons. The atomic number is the number of protons, and same is the number of electrons. So this is the electronic configuration for fluorine. So what two rules you need to keep in mind? Aufbau principle, that you always fill in the lowest energy level before you go to the higher one. Same is for the sub level. So S comes first, then you go to P, then D, and then F. Okay, starting from the nucleus. And sum of all the exponents should be equal to the atomic number. So let's do the practice from the periodic table. Let's do the electronic configuration for aluminum. Okay, aluminum has 13 electrons. So I'm not going to draw the circles. I want you to get used to doing the electronic configuration without the rings that I was drawing. So you know that you have energy levels. So energy level 1 will have only one sublevel. Energy level 2 will have two sublevels. Energy level 3 will have three sublevels. So let's do the electronic configuration now. Let's see how many electrons I can put in there. S can take 2, P can take 6, S can take 2. So how many it is already? 6, 8, 10, 12. I have one more to go. So I know P can take up to 6, but I am done with my number. So I will stop right here. So the outermost energy level for aluminum is 3, and it has 3 electrons in it. Okay, so this is how we do the practice for the electronic configuration. Let's talk about the other scientists. There are different scientists who played a lot of role in this electronic configuration and orbital notation. So Aufbau principle I explained already. It talks about filling in the lowest energy level first. So I want you to take a piece of paper and fold it like in the hot dog format, like in the lengthwise you fold it, and then you turn it into fold it into 4 more sections. So you need to make like 4 or 8 flaps like this. So once you do that, we can move on. So you need to do it in a way so when you pick up the flap, you can write underneath it. And then we can take notes on this. Okay, you can pause the video right here, grab a piece of plain paper, fold it in a way so that you can take notes and make 8 flaps of this. So let's move on. Let's talk about Heisenberg. Heisenberg was a scientist who said that the electrons are constantly moving. Okay, so we cannot find the location and momentum of an electron at the same time. So we never, either I can tell you where electron is, or I can tell you how fast it's moving. I cannot calculate both. So that is called Heisenberg's uncertainty principle. Okay, Aufbau principle, that atoms are lazy and want to have lowest energy. So you always, when you're filling in, you always start from the first energy level. Then you go to 2, then you go to 3, and so on. And same thing for the sublevels. You go to S, then P, then D, and then F. So this is Aufbau principle. Pauli said that each orbital can maximum hold 2 electrons. So these sublevels are further divided into orbitals. And each orbital can maximum hold 2 electrons. So based on that, I need 1 orbital for S, 3 orbitals for P. Let me explain it here. So I have S, P, D, and F. S can take 2 electrons, P can take 6, D can take 10, and F can take 14 electrons. According to Pauli's rule, Pauli's exclusion principle, 1 orbital can maximum hold 2 electrons. So basically the point here is that these sublevels are further divided into orbitals. So orbital is the space where there is maximum probability of finding the electron. Okay, that's what is called orbital, where you have maximum probability of finding the electron. Okay, so if according to Pauli, 1 orbital can hold maximum 1 electron. So I'm sorry, 2 electrons. So I need only, based on this information, I need only one orbital for S. P has 6 electrons, and if one orbital can hold 2, I need 3 orbitals for P. I need 5 orbitals for D, and I hope you can do the math by now that I need 7 for F. So the 2 electrons that I'm going to put in there, according to the next scientist, which is Hund's rule, that electrons will spin opposite, right? If one is moving clockwise, the other one will move counterclockwise. Okay, so, and plus Hunt said the electrons have to be distributed equally before you go back and pair them up. Okay, so I have 6 electrons for P. I'm going to do it again. I have 6 electrons for P. So instead of doing 2, 2, 2, I have to go 1, 1, 1, and then I have to come back and pair them up, because they all have the same energy, so they have equal right to get the electron. All these electrons that belong to the same P are called degenerate orbitals because they have same energy. So Hunt was a scientist who said that electrons with equal energy have the same right to get the electrons. So the electrons have to be equally distributed before you pair them up. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is how I distributed. Okay, so what I was talking about here was that Pauli said that one orbital can have only 2 electrons, and they have to move in opposite spin. So if one is moving clockwise, the other one moves counterclockwise. I mean, you can do full arrow or you can do half arrow. I'm just used to doing half arrow, so it doesn't really matter that you do a full arrow or half arrow. The point here is that if one is moving clockwise, the other one is moving counterclockwise to cancel each other's repulsion, because electrons have both electrons have a negative charge, so they repel each other. Okay, so to cancel each other's repulsion, they move in opposite direction. So this is what Pauli explained, that 2 electrons in one orbital move in opposite direction. So if you do it on the test and you do both in the same arrow, it will be a wrong orbital diagram. So when we show arrows like this, it is called orbital diagram. So Hunt was a scientist, it's a bus rule we call it, that you have to fill in the empty seats first before you double up. So you have to go 1, 1, 1 before you go back and pair them up. But this only applies to like P or D or F. This doesn't apply to S. S is only one orbital, and you have to complete it before you can move any further on. So this is all about electronic configuration. S orbitals is a spherical orbital. One sublevel, it can hold maximum of 2 electrons. P orbital, like the P has 3 orbitals, so you have to put 1 electron in each before you pair this up. Okay, D has 5 orbitals, and you have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It takes 10 electrons. And same thing you do for F orbitals. There are 7. So when you're doing this is called orbital diagram. So let's do some practice of electronic configuration and orbital diagram before I finish this up. All right. This is another way of doing the electronic configuration. So I think I will post another video for this one because it's going to get a little bit longer. So you have to watch 2 videos to complete this lecture. So I'm going to stop this one right here. You need to complete some practice questions, and as well as you need to complete some notes, your foldables on your worksheets. And then I will do the one more video to do the electronic configuration to do some practice of electronic configuration. All right, everybody. Thank you for your attention.